Determinants. First, we're going to look at a 2 by 2 determinant. It's also called a second order determinant. And if you'd like to see the derivation, it's in the textbook. But pretty much, you line up the coefficients of the x, you line up the coefficients of the y term, and you set up a 2 by 2 determinant with the straight lines next to each other. Each diagonal is used to multiply and to solve it. So the top diagonal is called the principal diagonal. It's also the positive diagonal, and the secondary diagonal is the negative diagonal. So that means when you're multiplying the second diagonal, you also have to put a negative sign within it, and just watch out for double negatives with the numbers. So solving, place a positive above A and a negative above B1. So a positive above A1 and a negative above B1. That's what I did here. Plus, minus, or if you look at this one here, plus, minus. Then you're going to use the principal and secondary diagonals to solve. So the principal diagonal, again, these are multiplied. Positive 3 times 6 and a negative for the secondary, negative 4 times 5. So the negative comes from here. So if one of these numbers in the secondary diagonal was negative, you would still have to add that negative as well. So when you put it all together, you pretty much, it turns into a multiplication and adding and a subtracting problem. So 3 times 6 is 18, 4 times 5 is 20. You have a negative there, so it becomes 18 minus 20, or the answer is negative 2. So we can use this to solve equations, but first let's look at another one that has a couple negative signs in it. So I put a negative 4, 3, negative 6, negative 2. You still put the positive above the top left, and then a negative above the top right. So you multiply the primary, so it's going to be minus 4 times a minus 2, and this is also plus, but the positive doesn't change anything. Minus, there's that minus, 3 times a minus 6, 3 times a minus 6. So I have negative 4 times negative 2 is positive 8. A negative and a negative is a positive. 3 times 6 is 18. So 18 plus 8, I get 26. Determinants can be used to solve equations. The denominator determinant consists of the coefficients of the variables. The numerator determinant for the x variable has the constant terms for the x column. The numerator for the y variable has the constant terms for the y column. Equations must be in the form of ax plus by equals c. So a is the coefficient of the x, b is the coefficient of the y, the constant terms are on the right-hand side, and those are called c. If the equation is not in this form, where the two variables are on the left and the constant term on the right, you do have to reorganize it before you start. So let's try these problems again. We've already worked these out with substitution and elimination. Now we'll try it with Cramer's rule. So x plus 4y equals minus 10, minus x minus 3y equals 9. So I'm going to set up the two sets of determinants. The x variable, when you're solving it, consists of a numerator determinant and a denominator determinant. And the y does as well, a numerator determinant and a denominator determinant. The denominator determinant consists of the coefficients of all the variables. So I have a 1 and a minus 1 for x, that's here, 1 minus 1. It's also on the denominator for the y, 1 minus 1. And a 4, negative 3, 4, negative 3, 4, negative 3. The numerator for the x, you can remember it by, if you're solving for x, remove the x column and insert the constant term. So the constant terms for the x go right there. The constant terms for the y go in the y column. So if you think of this column as x, this column as y, you take out the x column, put in the constant term, take out the y column, put in the constant term. So it's going to be constant term, y, x, constant term. And then you just solve. So I put all the positives and negatives in above each numbers, and you do the diagonals. So the first one's going to be negative 10 times negative 3, negative 10, negative 3, minus 9 times 4. So that's going to be positive 30 minus 36, which is a negative 6. The denominator is going to be 1 times negative 3 minus a minus 1 times 4, minus 1 times 4. So 1 times negative 3 is negative 3, minus times 4 is 4, positive 4. So minus 3 plus 4 is a positive 1. Negative 6 divided by 1 is negative 6. Once you have the denominator solved, it's the same for both. You don't have to do it again. Even though I went through it again, you do not have to do it again. It's the same number. All right, the numerator for the y is going to be 1 times 9, minus, there's my minus 1 times minus 10, minus 1 times minus 10. Just watch your negative signs. It's really easy to miss negatives. 1 times the 9 is a 9, minus, 3 negatives is a negative, so it's negative. 1 times 10 is 10. So 9 take away 10 is minus 1. Minus 1 over positive 1 is a minus 1, so my solution is negative 6, negative 1. Let's try another one. Negative 2x minus y equals minus 13. X minus 2y equals 9. Again, these equations are in the correct order, so I do not have to switch or flip them around or anything. Let's do the denominator first. Denominator consists of all the coefficients, so it's going to be 2, 1, minus 1, minus 2. Sorry, minus 2, 1, minus 1, minus 2. So it's minus 2, 1, minus 1, minus 2, minus 2, 1, minus 1, minus 2. All right, that's the denominator. So if you're solving for x, take x out, put in the constant terms. So it's minus 13, 9 here, and this still stays y, minus 1, minus 2. Solving for y, I take out the y and put in the constant terms. So the x stays the same. Notice it pretty much just carries up. Minus 2, 1, and these are my constants, minus 13, 9. I put in all my pluses and minus, plus, minus, plus, minus, plus, minus, and now I'm going to multiply my diagonals. So it's the negative 13 times the negative 2 minus 9 times minus 1. The bottom is going to be minus 2 times minus 2 minus a positive 1 minus 1, positive 1 minus 1. All right, so negative 13 times negative 2 is positive 26. And this is going to be a negative 9 times negative 1, positive 9, so that's 35. Minus 2 is a 4. Minus 1 times negative 1 is plus 1, so it's 35 over 5, which is 7. Again, I don't have to redo the denominator calculations because they are the same, so you can just put a 5 there. Numerator is going to be minus 2 times 9 minus a 1 times a minus 13. So it's going to be negative 18 minus a minus, so it's plus 13. So that comes out to a negative 5. Negative 5 divided by 5 is a negative 1. The solution is 7 minus 1. All right, let's look at the parallel and then the same lines. What happens when lines are parallel? What happens when they're the same line? Again, this is one of the examples we went over before. So I set my determinant up. Denominator consists of 1, 3, minus 1, minus 3. So 1, 3, minus 1, minus 3. 1, 3, minus 1, minus 3. Numerator for x, take x out, put in the constant term. So 610 minus 1, minus 3. Y, I take y out, put in the constant term. So x is the same, so 1, 3, 610. All right, now I go and solve. Let's do the denominator first. So it's going to be 1 times the negative 3 minus 3 times the negative 1 minus 2 times the negative 1. So 1, that's the negative 3, and this is plus 3. Notice denominator went to 0. All right, let's do the numerator. 6 times the negative 3 minus 10 times the negative 1. So it's going to be minus 18 minus, and the minus 1 is plus 10, so that's minus 8. Numbers do not equal, and you have a 0 on the bottom. This means their numbers are, or the lines are parallel, and there's no solution. And I did go ahead and solve this other one, but really you could stop here because once you know they're parallel, they're parallel. All right, let's see what the same line looks like. Set it up. 9 minus 3, 6 minus 2. So 9 minus 3, 6 minus 2. I only set up x for this one because I'm only going to do the one so just you can see what happens. But there is a y as well. I just didn't set it up. All right, take out the x column, put in the constant term. So 15 minus 5, leave y the same. So 6 minus 2. All right, denominator is going to be 9 times minus 2 minus a minus 3 times positive 6. All right, numerator, 15 times a negative 2 minus 5 times 6. All right, so 15 times a negative 2, it's negative 30, minus 5 times 6, positive 30, that made a 0. Minus 18 plus 18, that made a 0. So for this one here, both the numerator and denominator are 0. They are basically the same number, so you get the same line, infinite solutions. Looking at a word problem, a shipment of 350 cell phones and radar detectors was destroyed. Each phone was worth $107 and each detector was worth $159, and the total value was $46,446. How many were in the shipment? All right, so if I set my variables up, X is the cell phones, Y is the detectors. Since I have two variables, X and Y, I'm going to need two equations. As many variables as you have, that's as many equations that you need. The first equation is going to come from the total amount is 350. So the cell phones, which is X, plus the radar detectors, which is Y, is the total of 350. Now I can put the dollar value on each one. If the cell phones cost 107, it's going to be 107 times X. If the detectors cost 159, it's going to be 159 times Y. And that's going to equal the total cost. So I decided to solve this using substitution. So I took the first equation, I solved it for X. So I subtracted Y from both sides. So I got X is equal to 350 minus Y. And this gets to put in the opposite equation for X. So it's going to be 107 parentheses 350 minus Y plus 159Y equals 46,446. Distribute the 107, so it comes to 37,450 minus 107Y plus 159Y is equals 46,446. Subtract the 3750 from both sides, combine your like terms, you get 52y is equal to 8996. Divide both sides by 52, and it turns out that y is 173. So if I go back up here and look, I declared my y's as detectors, so there was 173 detectors. I go back and put 173 in this equation, and I subtract 350 minus 173. That gives me X, and my X at the beginning were my cell phones, so I have 177 cell phones.